Chapter 3, Class 12, Chemistry, Physical Chemistry. A topic, Electrochemistry. Okay. Electro chichu electricity, chemistry chichu chemical reactions. Here is in the chemical reaction akipan electricity modan bang, which is called electrochemical cell. Electricity akipana chemical reaction produced that is electrolysis. Basic electrochemistry topic cover due spontaneous process jiba, okay, non-spontaneous process jiba is in there. Why nona electrochemistry basic okay, spontaneous redox reactions. Mama redox is oxidation leondi, reduction leondi. Till ki gom homa electrochemical cells okay. Redox reaction seen on there. Wana electrochemical cell mindanga galvanic cell, mindanga voltaic cell. It is seen on there. Why example heavy taka study the Neihsial cell. Which cell representation banga jibang cell reaction bang chigeldi jibang. Electrode potential banga oxidation electrode potential jibang reduction potential okay, electrode potential jibang chini om there it is studied there. EMF of a cell studied on the which feasibility of a cell reaction okay, condition give free energy bang za hinga ekele E cell, EMF of the cell, positive demo, negative this. That is called feasibility of cell reactions. Feasibility is just spontaneity of cell reaction. Okay. Poimo mama Nernst equation given EMF of a cell. Calculation done. Tampi hidya numerical hidya tampi. Which a standard hydrogen electrode. Standard hydrogen electrode we studied here. तो नलामा electrochemical series ले ही दे. Theory ही कौन numerical tam थी लम. ये ले ची. अही भी ना spontaneous process बंगा. ची. Okay. यन मसला है. वही मध्य वना physical day-to-day life yo I mu the tui luang chi bang hakele metal rod langkhat aside the other end ki heat le apum pi haucha a heat pen pai so bang lum dak chi bang ma koite kha okay physical process ya tu ne study diwe le chemistry what is that spontaneous reactions ma. Example common ma. Okay, this one is spontaneous chemical reactions. Example bangzayam. Common mama. Nitric oxide. NO, this is nitric oxide. You react with oxygen. Okay. Product is NO2. Nitrogen dioxide. So basically, this is combination of nitric oxide and oxygen to form nitrogen dioxide suppose okay, this is called vacuum tube acquisition experiment vacuum a ball now okay cylinder say which is out paper on there where sunga bang ma omlo ale koi the okay suction pump til tang okay suck here which bang ma omlo then you put this NO and O2 in vacuum tube. Okay, what happens is NO2 is produced. Okay, yai kha external source le ton lo okay NO2 O2 hong ki su kha kim hi mo ki mu kha kim hi le they start reacting and NO2 kha hong ki product hong ki formula mo. This is a spontaneous chemical reactions. External panpi na bang mamlo amao okay process amao le mau payai cha NO2 to O2 okay reactant te omla I think NO2 ki produce the okay, process keeps on going. Example to spontaneous chemical reactions suppose charcoal okay charcoal bangle in leuch carbon is carbon okay you burn charcoal okay? Burn chichu oxygen in the presence of oxygen 2CO okay carbon monoxide produce the balance layer 2CO or 2 into 2CO okay so burning of charcoal yekha atunga external half of the halma sadima he need external sources but once it is started initiated it continue top tan carbon or charcoal abei tana reaction proceed this is called spontaneous external amlo hille reaction ki padwang lagle reactants te abei matan product ki form this is called spontaneous chemical reaction. Spontaneous chemical reaction omle non-spontaneous chemical reaction leom ngai china ete chu external energy source poimo dio okay product aki form tana atop tana reaction atop tana okay panpi na external la poimo gi yo example la banga chile okay electrolysis of water electrolysis of water okay beaker battery through here okay current produce suppose here electron neon there water is here electric apai sungteng reaction from the electric switch off nge le power supply na cut le reaction top de why chu spontaneous log china this is one good example of non-spontaneous chemical reaction. Spontaneous okay तो इसीलिए ले तो अतुंगाई मुते spontaneous chemical reaction है यहाँ तो इसीलिए spontaneous redox reactions redox is oxidation leon reduction leon revise what is oxidation okay OLE okay oxidation is what loss of electron ole what is okay example dem chang ale nak ta ka Neihsial study ding suppose zinc okay which is solid electron he lose 2 electron okay he lose to become one Zn2 plus mane Zn2 plus okay electron lose this is called oxidation reduction laba reduction is gain of electron Ge okay Rg okay ole Rg okay hello suppose okay copper 2 plus ions in electron ni gain tale product copper solid honge dema okay here there's a gain of electron so this is reduction here loss of electron so oxidation so electrochemical cell okay, oxidation to reduction process on talk that is called redox reactions, and it has to be spontaneous. Example nai pena kila thechu ye ane no le okay, ye sunga big beaker sungi chi yama. Okay, take one zinc rod and la electrolyte copper sulfate solution and the leochin. Okay, copper sulfate solution chichambang copper 2 plus on there, SO4 2 minus experimental observations are zinc rod reduce in weight. Yeah, zinc rod ola okay, so jet INC zinc rod reduces in size or weight. External power poimolo hetegeli koi khom le spontaneous reactions keep on null. So first observation is zinc rod reduce in size. Yeah, zinc rod size ni na copper sulfate solution blue even color okay, why pen blue color of solution fades away all blue pen mang so second observation is blue color of solution fade away. Observation thumna, yeah, okay, precipitate is a khalamom, okay, ya inoya zinc rod ya inoya kha, okay, red PPT, precipitate, okay, red PPT, kimuthe mo ya hangom mo pe. Alina, and then finally, okay, temperature, okay, temperature increases, temperature of the solution increases. A temperature bangzachi thi na de here again thermometer khat koi the again thermometer ne temperature increases. All observation yat lioma. So this is very much spontaneous redox reactions. Example hoi mamai. Redox reactions, oxidation to reduction omko michia and zonle. Okay, so oxidation bangom dele. So what happened? Zinc solid, zinc rod. Okay, zinc which is solid, zinc rod okay, he lose electron to become Zn2 plus. Okay, aqueous 2 electron. Ion state 2 electron. This is oxidation of, this is what? Okay, oxidation of zinc. Very good. Okay, reduction of bangita dele. Okay, yeah, copper 2 plus a solution on okay, copper 2 plus aqueous. He gained this 2 electron, okay, to become Cu solid. Okay. This is reduction of copper, COPP, right? Okay, process again happens at the same time. So this is called redox, and they are spontaneous because they don't need external source of energy. Okay. Yeah, it okay, redox, direct redox reaction ichi spontaneous redox reaction ichi okay. So del G, give free energy, thermodynamics give free energy has to be negative, okay? Less than 0 meaning okay, it is negative. Okay, del E, EMF of the cell, okay, EMF of cell has to be positive. You don't change a numerical tam okay, this has to be positive, this has to be negative. Okay, electrochemical electrochemical cell ai ke le galvanic cell ki che galvanic cell ai ke le voltaic cell detail de study diwa okay yay electrochemical cell example ya study mama kha Daniel cell L double I Daniel cell Daniel cell kha ichingel le okay electrochemical cell ha Daniel cell kha bangale okay zinc kha anot ki koi copper kha ki thot ki koi na okay why bana this is Daniel cell bana le pen ya mo okay ada ngom la ya okay ani na okay nickel kha anot ki jang chen silver ke thot ki jang oja thumna okay chromium le anot ki jang chen lead Eb at ke thot ki jang electrochemical cell noya jan electrochemical cell om the ya but poimo pen le okay study heavily study pen ha again Daniel cell ke pen ka sim masade so okay construction okay so Daniel cell construction either ne so construction anota okay anota zinc is zinc this is zinc rod okay cathode this is cathode copper copper rod ki cathode ka positive है anode का negative है electrochemical cell के connect ना current पहले थे ना ammeter anode lama electrolyte zinc sulfate की जगह zinc sulfate solution cathode lama you put copper sulfate solution copper sulfate okay so anode lam okay this helam kha it's called anode half cell anode half cell again this is reactions half khayalama omjaken it's called anode half cell AHC helam kha cathode half cell cathode half cell reactions so in anode half cell oxidation happens so oxidation bang chale. Okay, yeah, so zinc solid, he loses electron to become Zn2 plus aqueous. Cathode lama reductions. Okay, copper solution. Okay, here solution as U2 plus SO4 2 minus of energy. Zn2 plus equals plus SO4 2. So reduction of what happens? Copper 2 plus equals after gaining 2 electron become copper as solid. Okay. And it is here Zn2 plus. You went to the solution alludes okay, to the solution. Okay. Yeah, 2 electrons, copper in and again, and copper 2 plus in and again, penha, rho tang pai, and left now, so Zn2 plus, he lose 2 electrons, and he went to the solution. Yeah, 2 electron tekha ya rho ta pai to. Okay. Yeah, payo travels throughout again, and yeah, and copper 2 plus equation gain to become copper solid. I leach a process on paita here current, not current, electron from anode to cathode on pipe view. I lay it bangaha, it is a direction of electrons are opposite directions of current. Electron te ya pai le current ya lamang le pai. Okay, current and electrons are opposite in directions. I lay a process on pipeta. Okay. Why madam anode bangsan negative picture? It's because there are lots of electrons over here. So electron test sign ha negative. Okay. Good. I lay. It's a process again. Zn2 plus a solution I loot so Zn2 plus solution loot Zn2 plus tam de Zn2 plus Zn2 plus. It's a anode half cell. Sometimes we call it left half cell, left like LEFT. Right half cell, left half cell. But we will use anode half cell. Okay. So Zn2 plus a solution on tam de changa bangchi. Okay. On tam de changa electron flow of electron ka on subaita. Okay. So positive tam de le electron te ya on by second gen. Okay. So electron te pai thelo so okay. Problem hom ta. Why mabanga here bangchi? Yeah, copper here paito copper solid tungge yama. So sulfate SO4 2 minus SO4 2 minus SO4 2 minus SO4 2 minus tam de negative. Okay, negative charge tam de china. Which here electron on paison sunte to SO4 2 minus teka ki repel ta. Okay, so okay, cathode half cell is full of SO2 minus ions which repel incoming electrons. Electron on paitata ki repel ta because like charges repel each other. A solve the solution on sunchu banga. Okay, uses the solution is the uses of Sol bridge, SALT BRIDGE, Sol bridge. Sol bridge poi mo na le construction new chi gen be dia. So sol bridge kai chi dani. So dena igel I diagram pen ma jang non le. Sol bridge okay, generally it looks like this. Sol bridge. Okay, it is a inverted U tube, okay, glass and inert electrolyte asunga ki koi. Okay, ini ma jang ne la. So come here. This inverted U tube glass, okay, asunga inert electrolyte. Inert electrolyte bangjang ki chise ya. Dem changa detail in kon gen dia. Inert chichu they are not reactive. Till dang chemical dang to ki reaction on lo. Okay. So yeah, side again. Yeah. So Sol bridge uses inert electrolyte. Inert electrolyte take up coca chile, suppose potassium chloride, okay, potassium sulfate, KNO3, tangpia potassium chloride, okay, kisangan chen banga chile, suppose lama positive charge full ile and ions penang paisu chloride ion penang paisu, then okay, you will neutralize negative ions, neutralize this positive charge over there. Alangkha the potassium K plus yalang pai the ya negative ions tam pite khaman va neutralize. Okay, in that way the status quo is restored. Okay, ucha like cell reactions pai chom thina. Okay, sol bridge function poimo mama. So okay, function of sol bridge. Okay, karena it maintains the electrical neutrality. Okay, it maintains the electrical neutrality of the half cells. Mahaya positive tamlo yalam negative tamlo ille sol bridge on kizatta ki pana solution ka neutral hongita, right? It completes the circuit by allowing flow of electron again. Okay? It completes the circuit by allowing the flow of electron. Tu ma electron le paithino lokha to ama sol bridge ki zatta ka electron flow te resume thita. Okay. A main function of sol bridge, main function है तो ये लगी है. Okay. Next cell representation. Cell representation. Cell representation. Okay, so rules name chikoma. Okay, another half cell is here. Okay, oxidation half cells. Dekha avela makiyap ma kikoi. Yes, on the left. Okay, yes, on the left. Igel changa. Example LEFT. Igel example on pelang changa. Okay. Number 2, okay, reduction half cell. Reduction half cell is written on the right. On the right. Okay. Athumna sol bridge. Okay, is represented by okay, yeah, double line. Saudi okay. Omdan chu bang. Example of bang, okay? The Neihsial ma n no nile. The Neihsial bang. The Neihsial is oxidation. Okay, oxidation half cells bang zinc rod in okay, zinc rod in zinc sulfate solutions. So zinc solid pen he become zinc 2 plus ions. This is oxidation half cells. This is my oxidation half cell. Oxidation half cells. Ekha velama koide. So Zn solid. Okay. So keep equation. Zn2 plus equation. Okay. This is your oxidation half cell. Velama koi. Akala sol bridge koi. Ye symbol. Then reduction half cell bang chigaldi. Reduction half cell. Okay, reduction half cell is given by what? Copper 2 plus equation. He gain 2 electron and become what? Copper Cu solid. Okay, Cu solid. So this is your reduction half cell. Taklama koine. Cu2 plus equation and then Cu solid. Yeah, this is the complete cell representation. Okay, so here so question for my udle. So write the cell representation, okay, for the Neihsial. Okay. Numeric question nakhat is only cell representation to say. Okay. So suppose okay, chromium solid and okay, anode half cell, oxidation half cell, okay, chromium and 2 electron loose and then he become Cr3 plus equation, oxidation half cell. Okay. Reduction half cell, say suppose let Pb2 plus equals after gaining electron, okay, 2 electron become what? Pb2 solid. Okay. How hydrogen okay, cathode half cell, actually reduction half cell, particularly this will be Pb2 plus equals slash Pb solid. Okay, this is your reduction half cell. This is your oxidation half cell. Oxidation half cell, why? Okay. Chromium solid in a you lose electron. How much? 3 electron to become Cr3 plus. Oxidation half cell, reduction half cell is given. Okay, yeah, then write cell representation for this. Cell representation will look like this. Okay, representation will look like this. Alaya sol bridge ni. Okay, reduction half cell bang right koi 2 plus equation slash 2 Pb let solid. Oxidation half cell velama koyole Cr solid Cr3 plus equation done. Charangel din. Bana cell reactions. Okay, cell reactions. Why cho oxidation to reduction process geldi top na the final reactions geldi. Example the Neihsial malanoni. So take example the Neihsial. Okay. So oxidation half cell, oxidation oxidation happens. So oxidation half cell looks like this. Zinc, which is solid, he lose 2 electron, yeah, to become what? Zn2 plus equation. Done. Thank you. Reduction half cell abang copper 2 plus equation after gaining 2 electron, becomes copper solution. Okay. Here 2 electron cancel. Bangomlai here Z10 solid plus here Velama Tengom form equals 2 plus equals copper. So this is the required cell reactions of the Neihsial cell. Okay, question of I think answer is so write the cell reactions for suppose nickel solid Na2 plus equals solid bridge reduction cathode lama silver aqueous and then silver solid. Then cell reaction okay. Oxidation half cell okay. So nickel solid after losing 2 electron become Na2 plus aqueous. This is oxidation half cell reactions. Oxidation is it, Micah? Yes. Oxidation. Oxidation. This is reduction. Reduction half cell. Silver. Okay, silver. Okay, this is equals plus 11 positive charge kat so he will take only 1 electrons to become what here over here. Okay, silver solid. This is reductions. Okay, see this is equation 1, this is equation 2. Okay. And they will here number of electrons are not balanced. Here 2 ohm, here 1 ohm. Amasa high balance put. Okay. So equation 1 to 2 ohm ki baat the equation 2 you have to multiply by 2. Okay. Equation 2 multiply by 2. Okay, so equation 2 multiply by 2, 2aq plus aq ag, okay, 2e electron, 2ag solid. Equation 1 to as it is something. Na2 plus equals plus 2e. Okay. Electron take a balance cancel theta. 2e. So what is left? Ni solid plus Velama Tengom from 2ag plus equals Ni2 plus ag plus 2ag solid. So this is your cell reactions. Okay. Numerical khati lai le. Question number 3. Cell reaction. Write cell reactions for chromium solid Cr3 plus. Okay. Concentration is given 1 molar. But we don't require concentration PbS. Okay. Cell reaction practically answer. Okay, oxidation half cell kilo. This is your oxidation half cell. Cr3 plus equals plus 3e. Okay. This is your oxidation half cell. Reduction half cell. So Pb2 plus equals plus 2e. Pb solid. Okay. Equation 1, equation 2. And electron take a balance loan on. So what should you do? You multiply this by 2 and multiply this by 3. Okay. Okay. So so this has become 2, 3 or 6. Here 6 electron. Here 6 electron. You can cancel. itu lah 2Cr solid plus yang nama 3 Pb 2 plus equals yang nama 2Cr 3 plus equals plus 3 Pb solid, right? This is your cell reactions. Oleh electrode potential. Next topic, electrode potential. Okay, XII khatna oxidation electrode potential. Oxidation electrode potential, reduction electrode potential. Okay, we am done to Electron. Okay, oxidation chi banga chi le definition alu thak thak le. Okay, if the metal says suppose zinc okay, loses electron, that is oxidation. Bangchi in the process okay, metal M is losing electron Mn plus Ne. Okay, the number of electrons in N to here N ki bangte. Okay, then I move 2 plus 2e chite. Why done dewa? Okay, so the potential difference between the electrode and its ion. Then velama oxidation half cell I lack kwa zinc rod in what? Zinc sulfate. Okay, zinc sulfate solution. So potential difference between the electrode and its ion. Potential difference between zinc and its ion Zn2 plus. Okay. A metal so same electrode okay, potential difference involve whatever it is. Okay, it's called electrode potential. So okay, by equation okay. And if there is a here process oxidation, this is oxidation. If the process is oxidation, this is called oxidation electrode potential. If the process is reduction, it's reduction electrode potential. Reduction okay, reduction lamalek bangchi okay, copper mention copper ma electrolyte ma copper in copper sulfate solution. The potential difference between this copper electrode and copper 2 plus ions, this is called the electrode potential. And since okay, this happens, this reaction take place at the cathode half cell, like a reduction half cell. Okay, why is that? Reduction electrode potential. And oxidation half cell which electrode okay, potential difference between the zinc and zinc ions. Oxidation half cell is called oxidation electrode potential, right? Reduction lama okay, what happened? Metal after okay, metal ions after gaining some electrons, not 2, this should be N, okay, to become metal. This is how you represent reduction in reduction electrode potential, right? So next he dikha EMF of a cell, electromotive force of a cell. It will be in the forms of formula. Diagram drawn only. Elama what? Copper in copper sulfate solution. Okay, zinc in zinc sulfate solution in the Neihsial. So, element oxidation, reduction. Continue represent metal has become Mn plus Ne. Element M and N plus after gaining Ne electron. N plus, if the gaining electron become M. So this one we call it oxidation potential. Oxidation potential and reduction potential. Okay, oxidation potential, short form OP, RP. Oxidation potential. Okay, potential is again, so we start using either V or E. Okay, E for what? EMF, electromotive force. Okay, it's a potential. So E, oxidation potential. How will you represent? M/Mn plus. Exact. Okay, the metal zinc has become, after losing 2 electrons, become what? Mn plus. Ion circuit form. Okay, so this is how we represent oxidation potential. E subscript M/Mn plus. Reduction potential E, ions the metal ion N plus and then M. Value say suppose 0.2 volt plus 1.8 volt. So finally, EMF of a cell, formula EMF of a cell will be, okay, oxidation potential, short form OP, okay, potential, oxidation potential at anode, okay, and then plus, okay, reduction potential is ERP at cathode. Right? Okay, oxidation potential at anode, reduction potential at cathode. Right? Okay. Oxidation potential at anode is just opposite process for reduction potential at cathode. Okay, so okay, process oxidation, reductions. We can keep minus over here. And the IUPAC, International Union of Pure and Applied Chemistry, this committee, EMF of a cell defined reduction potential velum to taklama, velum chichu anode lam to cathode taklama. Reduction potential EOP so EOP has become what? ERP. Okay, ERP. EOP at cathode anode is equal to minus ERP at cathode. So you have cathode, okay, plus ERP at cathode. So ERP. Okay, so sorry, this EOP is the opposite side of reduction potential, but this is for the anode, right? So this cannot be, this has to be anode. This is cathode. Okay, yeah, EOP XII. So plus lamon ko ERP at cathode minus ERP at anode. Okay, this is the perfect definition for EMF of a cell. And reduction potential and then minus is in between. Cathode lamai, anode lamai. Okay. Okay, okay, EMF of a cell is what? Okay, reduction potential, okay, at the right minus E left, reduction potential at the left. Yeah, again, okay, okay, E right minus E left. This is this oxidation potential or reduction potential? Okay, so definition It's all about what? Reduction potential at cathode and reduction potential at anode, and minus is aligned. Okay. Now check numerical is all there. Suppose questions. Okay. Fine. Okay. Why yeah, EMF is given by this. Okay. Standard EMF Chile. Standard EMF teacher. Okay. Standard conditions is temperature 25 degrees centigrade and 21st in terms of kelvins 298 is equal to 298 Kelvin. Okay, pressure is 1 atmosphere, 1 atm or 1 bar. Okay, these are standard conditions. So standard condition are EMF nazonule, then EMF equal to EMF of a cell. Sometimes it's written like this. Okay, EMF of a cell was reduction potential at cathode, minus E reduction potential at anode. This is the normal definition for EMF, E cell. Okay. EMF, sometimes you can write E cell. Okay. Standard EMF actually not na koi dekha. Okay. E naught equal to E naught RP at cathode minus E naught RP at anode. Okay, standard EMF. Numerical so question is find the standard cell potential of okay, reactions. Suppose nickel Ni2 plus 1 molar concentration, salt bridge, silver plus 1 molar concentrations, and silver, Ag, silver. Okay. Standard EMF, this N plus slash, this is given 0.25 volt, and E naught for silver also has to be given Ag plus Ag, right? Plus 0, okay, plus 0.80 volt, right? The answer is we have the reactions this. And reactions Ni2 plus 1 molar, okay, and then silver, okay, 1 molar Ag slash Ag, right? Ag. So left. So this is what your oxidation. Oxidation half cell. This is your right. Okay, reduction half cell. Okay, reduction half cell. That means what? Right side is the cathode, left side is the anode. Reduction potential at now reactions. Reaction is this oxidation or reduction? Yeah, it's reductions because Ni2 plus gains 2 electron to become Ni. Silver plus gain 1 electron to become Ag. Reduction potential. This is reduction potential, very much reduction potential. Value okay. And okay, E standard not cell. Okay, E not cell. Standard EMF of a cell is given by this. Okay. Then again E naught reduction potential at cathode. Cathode ko silver value minus E naught reduction potential at anode. Yes. Okay. A value silver. Who is that cathode? Who is that cathode? Silver. Silver value over here is 0.80 minus RP. Okay, reduction potential at cathode. Who is cathode? No, anode aqua nickel. Nickel value is 0. Okay, minus 0.254. So you go home legend 0.80 plus 0.25, okay, then 5 and then 0.10 volt. Okay, EMF of a cell calculate that here. Okay. Next, okay, feasibility of cell reactions. Feasibility of cell reactions. Feasibility, okay, of a cell reactions. Okay. Feasibility meaning spontaneity of a cell reaction. Yeah, then again, okay, give free energy bangzahidi, and then okay, Neihsial bangzahidi. Okay, so give free energy will be negative, okay, less than 0, and Neihsial will be positive, which is greater than 0. Anyway, so for any spontaneous reactions, Bangale conditions, then again, give free energy has to be less than 0, meaning negative. Del G has to be negative. Okay. Negative is negative of what? Negative of what? This is actually useful work, negative of useful work done by the thermodynamics, useful work done by the system, right? Okay. Useful work done by the system. Negative of useful work done by the system. This system of Bangal, useful work done by cell, electrochemical cell. I lay useful work Bangale, okay, useful work useful work okay, it's a electrical work, okay, minus W. This is electrical work. This useful work done by the cell is an electrical work. W work, yeah, done by the cell. Very good. Yeah. What is electrical work? Yes. Okay, so what is electrical work? What is electrical work here? Okay. Voltage change is work done by an unit charge, right? Okay. Del nu, no, okay, del V, okay, it's a amount of work done divided by charge. So W Zomuti, so dV Q, right? Q is the charge, del V is the potential difference. What is this? Q is the charge, okay, dV is the potential difference, right? Okay. Diagram neotic draw ngaya here. Now okay, okay. Yeah, okay. Oxidation half cell, electron on pi. Electron is coming, okay. Delta again, no loading. Electron on pi. Electron is coming. Number of electrons, okay. Number of electrons transferred to the cathode. Okay, we don't know, so we'll call it n number of, n mole of electron is going towards the transferred to the cathode, right? Transferred to the cathode, okay. Yeah, minus positive, right? Anyway, what is Q? This is charge on one electron. Q is charge on one electron, and this has to be multiplied with n. Okay, number of electron he put like, okay. Q is charge on one electron, and there will be, okay, how many number of electron? N number of electrons. So Q, which can be written, okay, charge on one electron is 1.67 into 10 to the power minus 19 coulomb. Yes, okay. and n number of electrons. How many number of electrons get transferred? N number of moles. And it's all about moles. Moles is Avogadro number 6.022 into 10 to the power 23. So Q finally has become n. Here multiply leuchin. Simplification bolochin. What you get is 96485 coulomb. Okay. 96485 coulomb bangale. This is charge on 1 mole. Listen. Charge on 1 mole of electron, which is called Faraday. 1 mole of electron charge it's called 1 Faraday. Okay, 96485 calculation and observe the 96500 coulombs. Okay, 96500 coulomb we can represent by F, NF, okay, Faraday, F for Faraday, okay, Q equal to NF now, okay. Equation 1 is the way happen, alright, okay, equation 1 is what? Equation 1, W equal to del V Q, right? This is equation 1. LG. Okay. So this one. Okay. Del G del G equal to what? Minus W, right? Del G equal to minus W. Del G equal to minus W is what? Del VQ. Okay, del VQ. As actually equation 1 this is from 1. Okay, from 1, right? So finally del minus na kada, okay? Is, okay? Yeah, nail check. Now then, del V. This is E, okay? EMF of a cell. E cell. What is Q? Q is NF. Yeah, Q is NF. Here, over here. See equation 2. Okay, let's say from 2, right? So finally, del G has become minus NF E cell. Yeah, here del G give free energy full form, final form. Okay, yeah. Okay, del G is what? Give free energy. Change in give free energy. Okay. Change in give free energy is equal to minus NFE. F is Faraday. Is the Faraday. Okay. E is the EMF of a cell. So here term ting. Okay. Here term ting is the electrical work. We can say it's an electrical work. Useful electrical work. Okay. Which has to be positive. Here term ting. Okay. Here negative. Del G negative hai thena de. Here part positive hai nga. Bang jaiken. Del G negative, this whatever on the other this part has to be positive. Minus into plus is minus. So del G has to be negative. So we have these equations. Okay, for feasibility. We have two conditions. Del G has to be negative. That means del G less than 0, and E cell is a constant. Okay, this is a constant. So E cell has to be positive, greater than 0. That is, E cell has to be positive, right? This is two condition. Feasibility, spontaneity. Okay. Numerical khatkon hi pi dia. Question kilo lah. Okay. Find the standard free energy change and predict feasibility of Daniel Celan pe 2 1 molar copper 2 plus 1 molar copper. Okay. Some EMF, standard EMF are given. So 2 plus ZN minus, this is minus 0.76 volt. E naught copper 2 plus copper and oxidation reduction potential direct as a theme. Hence oxidation potential on pension meaning a metal penang masa wachanga ya value a heg de assign on khat minus le positive jadi ma. Okay, 0.4. Okay, we know 1 Faraday is also 1 Faraday is 96.0. Okay, so E cell answer. Okay, E cell is given by what? E naught cell. E naught reduction potential of the cathode is the cathode. Copper is the cathode. Right side on papa cathode. Avail on papa anode. Anode half cell. Cathode half cell. Minus E naught. Okay, reduction potential at the anode. Okay. Cathode aquam copper. Copper has plus 0.34. Okay, minus. Okay, so the other one is zinc. Okay, anode 0.76 volt. 0.34 plus 0.76 1.1 volt. Okay, E cell a positive value. Yes, this is very much a positive value. Okay, okay, feasibility condition E cell has to be positive. Yes, satisfied. Very good. Del G naught is given by what? NF E naught cell. Yes. Then I have del G equal to minus NFE. Mana E? Okay, standard give free energy here. Not quite okay. NF E naught cell. This is a constant, so you don't need to keep mana. Yeah. So minus yeah, N how okay, number of electron involved. N less than 2 plus. He gained 2 electron. He gained 2 electron. So N value is on here. So at oxidation, what happened? The solid after losing 2 electrons become 2 electrons. After losing 2 electrons, it become 2 ZN 2 plus. So this is oxidation. Okay, this is reduction. Copper 2 plus after gaining 2 electrons becomes Cu. So, okay. How many number of electrons are involved here? Look, N equal to 2. Here 2, here 2. Number of electrons are transferred. 2 electrons are transferred. 2. Okay. F is we know 96500. And the E cell, that I calculate heat jet volt. So, okay, he legend. What you should get is 300 joule. Okay, del G naught is equal to this much, right? So del G is what? Negative. E cell is what? Positive. So this reaction is visible, right? Nurse equation. Numerical tampioma hoitena ana practice na ki collect on no koi ana practice. Okay. Very important topic. Okay. Nurse equations. Nurse equation. Nurse equation le okay. EMF calculation le pata home ya. So okay, at any concentration or at any temperature, EMF of a cell calculate at any concentration or okay, at any temperature. This is the advantage. Okay, advantage of Nernst equation. At any concentration and at any temperature, you can use Nernst equation to calculate what? EMF of a cell. So, okay, this is E cell. EMF of a cell is okay, E naught. Okay, standard EMF of a cell minus 2.303. Okay, gas constant RT, temperature in Kelvin, 298 Kelvin. This is divided by okay, NF. Okay, N is number of electron involved, and F is Faraday. Okay. And you have this logarithm of base 10 into okay, this is concentration of the product and concentration of the reactants, right? Okay, Nernst equation here. Okay, simpler form. Yes, okay, simpler form. This is okay. E naught cell minus okay, 2.303 okay. Logarithm neochic revised balls only. What is logarithm? We have two okay. One is natural logarithm, okay, natural base, okay. One is logarithm of base 10, okay, base 10 natural logarithm akipana ln, which is represented by ln. Okay, logarithm of base 10, which is given by log subscript 10. Now convert this is the converting factor 2.303. Okay, what is R? R is a gas constant. Okay, R is a gas constant whose value is okay 8.314 okay into okay 8.3 joule mole. And then okay, inverse per joule okay, per mole per Kelvin, right? Okay, 8.314. Very good. And temperature RT, temperature is always in terms of Kelvin. Okay, it's 298. Okay. And F is Faraday. We know 96500 Coulomb. And then this is P. This is concentration of the product. Concentration of product. And R is concentration of reactants. Concentration of reactants, right? Yeah. Yeah, value te ban koilechin. Male, yeah, R value TF again koilechin. What you get is 0.059. And oil n koidi number of electrons involved. We don't know in its okay. In its case, n will be different. Reaction atom is n will keep on low. Log of base 10. This is product. Okay. In textbook log of, you'll see log of base 10 concentration 1 divided by concentration of 2. Okay, so concentration 1 okay, concentration of product concentration C2 is concentration of reactants. Okay, numerical ki hazard mama diha is Nernst equations. This what is this reduction ratio of concentration of product to the concentration of okay, reactants. It is called reaction quotients. This is reaction quotients. Reaction quotient. CUOTIENT, right? Okay. Numerical is clear. Okay. Find. Okay. Find the reduction potential. Okay. Reduction potential like oxidation potential. Oxidation potential okay, of Cr solid is going to Cr3 plus 0.1 molar okay, at 25 degree means 298 Kelvin, 25 degree or 298 Kelvin. Okay, so what is given? E naught Cr3 plus Cr, which is given by 0.76 volt. And okay, yeah. Answer. Now another. Yeah, this is reduction potential. Right? reduction potential here. This is very much reduction potential, right? E naught Cr. Okay. What is reduction? Okay. Reactions for reduction potential. Reduction potential. Okay. Cr reduction is gain of electron. K plus 3E, you will gain electrons and chromium solid, right? And all. So here ion spin her reactance and yes, and the product is this. This is concentration of the reactants. This is concentration of the product. And IUPAC has made this rule reduction for concentration of any solid or liquid, pure solid or pure liquid is always taken as 1. Okay? But concentration of these ions, they will be given. Okay, yeah, 0.1. How much is it? 0.1. 0.1 molar. Okay, you can remove the point here, 1 by 10. So you can write 10 to the power minus 1 molar. Okay, then yeah, equation 1. Now this equation apply yeah, okay. So for this is pure solid, so concentration is 1 as per IUPAC rule. And all okay. Nernst equations. Using Nernst equations, E cell is equal to E naught cell is given. Yeah, E naught cell. Okay, minus 0.75 volt. Okay, minus 0.059. Number of electrons involved is how much? 3. Look at this. N equal to 3. Right? Number of electrons involved is 3. Right? 10 to the power 10. Log of base 10. Concentration of product is 1. Yes. Concentration of product is 1. Concentration of reactants is minus 1, right? Minus 0.75. Okay. Now, calculation of zonary, this can be written as this is greater than 5. You can round off 0.06. Yes, 0.06. 3 and alone. Look of base 10. 10 to the power 1. Okay, and you should remember 10 to the power 10 log of 10 to the power 10 log of 10 is 1. So here thing 1, so okay, minus 0.75 minus 3 1 is this is 0.02. 0.02 into log 10 is 1. Okay, this is how much? 0.77 volt. Well, again, Nernst equation. So now. Okay. Abana, okay, electrochemical series. Now we can okay, wait, standard electron. Why am I doing that? Sorry. Okay, standard hydrogen. Okay, standard hydrogen electrode. Standard hydrogen electrode. Okay. Short from She, right? SH. Yeah, banga. Enjoy there. We more mama. Standard hydrogen electrode is sometimes called normal. I mean, the normal hydrogen electrode like NHE. Okay. Electrochemical cell like the Neihsial. It is a gas ion electrode. Gas to ion electrode diagram. Meaning, what is the gas used here? Okay, hydrogen is here. Hydrogen is a gas. On the hydrogen H2 has, and the ions is H1, H plus ions. Okay, ions aqueous. It is a gas ion electrode. So how will you represent H2/H plus equals? This ions from where? It's from the solutions. Where's again a diagram drawn like that? You know, beaker khato mention. Okay, this is a beaker or vessel. You call it vessel. Yeah. Experimental setup. Okay. This I call glass jacket. Glass here structure form. ya kha ya kha platinum, okay, platinum black foil okay, inert electrode, platinum electrode, platinum electrode lagi zanga electrode, okay. Ya neo chik sik big ding ding khatoma. This is platinum electrode. Ya neo chik holo inert electrode ngai. Bang ma thildang to kirek loading. Koi jaga platinum kisang. Platinum jaga is very unreactive. Koi jaga platinum kisang. Ye bang platinum black foil. Platinum akibolma, okay. Black foil, foil chichu aluminum bag dan dewa cha bag dil dal ma, okay. So platinum black foil, what to observe, to absorb or adsorb. This is forward to absorb or adsorb the gas, hydrogen gas ya kang pai sugai. This is a small inlet where pure hydrogen gas is passed. Okay? This is a small inlet, inlet where pure hydrogen is passed. Okay. Well, to absorb hydrogen gas. Very good. Yes, sunga tuya bangai koi wichile. HCl acid, strong acid cut. Say suppose HCl equal mana. HCl break up jabang H plus Cl minus. H plus ions are here tamai. Okay. H plus ions are here. Okay, H plus ions, the concentration is given at 1 molar. Okay? 1 molar HCl is kept here, right? Okay. Construction here bang hila. Okay, this standard hydrogen electrode to say point first kaya. It is a gas ion electron. Gas H2S gas is passed on and H ion in the solutions. There's an equilibrium between them. So okay. Point number 2. It is a reference. Okay, electrode. It is a reference electrode is set by IUPC, International Union of Pure and Applied Chemistry. Omdan chu chemical dang te redox okay, potential te kha hydrogen redox potential to compare gi here. So hydrogen, okay, this standard hydrogen electrode, this is taken as standard reference. Very good. Point number 3. It acts as both anode half cell as well as cathode half cell, and its standard oxidation potential, standard oxidation potential or reduction potential. Okay, standard oxidation or reduction potential is assumed to be 0. Potential is assumed to be 0, meaning E naught, okay, this reduction potential H2, and you will now balance this is 1 hydrogen atom, this is 2. So if you put half here, half into 2 is divided, okay, cancel, then this is 1 hydrogen. So its reduction potential is 0 as well as oxidation potential. Hydrogen yellow, okay. So H2 H plus okay, balance level. This is also is taken to be 0. Why not? Okay, point 4 now. There is equilibrium. Okay, there's equilibrium conditions. Yeah, equilibrium between. There's equilibrium between H2S gas. Okay, then H2S gas. Yeah, H2 gas ang paisuk pianto. Hydrogen ion in the solution. There, H plus ions in the solutions. in the solutions. Okay. Equilibrium between each gas and H is established. Okay. In terms of reaction, you will write like this: equilibrium sign on the plus. Okay. This H2 is where? In the platinum black. In the this is in the platinum black. This is in the solution. Okay. So point number 5. Yeah. Okay. So when standard hydrogen electrode XS anode half cell okay, how does that the reactions looks like? 2H plus and 2E. Cell representations, how will you write cell representations for this? PT brackets on H2. Okay? This H2 is in the platinum slash H plus equals. So yeah, again here. E naught half H2 for oxidation. For oxidation, half cell H plus. This has to be 0, right? Point number 6. Point number 6 are okay, when CX reduction half cell, cathode half cell, reduction half cell, how will it look like? Okay, H plus in a electron again he become H2, right? H2. So the cell representation will look like this. Cell representation. So E naught. follow. H plus in a quash slash H2 in the okay. This is in the form of gas. So E naught. Okay, H plus half H2. This also has to be equal to 0. Okay. Okay, last topic dunia dia. Okay, electrochemical series. Okay. So ECS. So in this electrochemical series, bangal elements to okay, nitrogen, oxygen, zinc, okay, different hydrogen, alike adang thing, okay, are arranged in order of what? In order of increasing standard reduction potential. Standard reduction potential. Element thing about standard reduction potential nature to SRP. Okay, I don't say. So in then again SRP is all this SRP standard reduction potential values are taken with respect to hydrogen standard electrode, which is 0. Hydrogen then standard hydrogen electrode hydrogen electrode potential oxidation and reduction okay, both are 0. With respect to hydrogen reductions, which is 0 reduction potential, which is 0 volt. Okay. Now is a table and SRP for let's see. So reactions, suppose lithium Li. This is all about what? Reduction potential. Li, so he will gain electron, Li plus electron, so he become Li. Okay, how will you represent? The cell representations look like this. Cell representations. So E naught, okay, Li plus hyphen. Okay, this is so SRP value for lithium is minus 3.054, right? And next adang leum there, but a poimoting kungil zone Zn2 plus 2 electron, right? Okay, so Z, right? So E naught Zn2 plus 1 Z, right? So minus 0.706, okay, 0.6 volt, this is 6. Okay, iron on next iron, we lose 2 electron, and we gain 2 electron, becomes E naught Fe2 plus Fe, which value is 0.45. Okay. Wait, hydrogen last topic. So 2 plus hydrogen 2 electron. Okay, this is E naught H plus slash half H2. Okay, this is 0 volt. Hydrogen is taken as standard, right? It's taken as standard. And we have Cu2 plus 2E electron copper. So cell representation will look like this: Cu2 plus Cu. The value is plus, and hydrogen plus minus and plus. Copper, silver, okay, silver, E electron, silver, E naught Ag plus Ag, okay, this is plus 0.80 volt. Okay, silver, what is it? Fluorine F2, okay, 2E, okay, here 2 of F minus, okay. E naught F2 F minus, whose value is plus 2.87 volt. Okay, I am done, sir. Okay, tendency to get reduced, okay, increases. Yeah, no tendency to get reduced, increases. Reduction process, yeah, no term that means, okay, this will be tendency to get oxidized increases, opposite k. Why okay? So lithium, lithium is the best reducing agent. Lithium, this is the best reducing agent. Okay? Fluorine will be the best oxidizing agent. So fluorine is the best oxidizing agent. Okay. Here to say question tam piom thea. So here value te by hata just solve it. Okay. Yes, I enjoy